Hello everyone, in this video we will solve a three-dimensional example using a method of variation of parameter. So the question is using a trial wave function psi of r bar is equal to c raised to minus alpha r, where c is a normalization constant, alpha is a variation of parameter, estimate the ground state energy of a hydrogen atom. So it is a hydrogen atom problem where a trial wave function is given. Our first task is to find capital C, which is a normalization constant. And you know how we can do that, so it's integration dq bar and this should be equal to 1. Now let us substitute this. So c square e raised to minus 2 alpha r. Now you know the trial wave function does not depend upon theta and phi component in spherical coordinate, so we can just use this dq r bar, replace it with 4 pi r square dr, and a limit will be from 0 to infinity, and this is equal to 1. And now it will give me 4 pi c square 0 to infinity r square e raised to minus 2 alpha r is equal to 1. Now if you look at this integral, we know we can use a formula to solve this integral. It is nothing but a definition of gamma function. So if you recall, the definition of gamma function is what? If there is integral from 0 to infinity x raised to 1 e raised to minus ax, if this is the integral dx, then integral is gamma n plus 1 upon alpha raised to n plus 1. And you know what is gamma n plus 1 is nothing but n factorial upon alpha raised to n plus 1. Provided n is an integer, then only I can represent this gamma n plus 1 as n factorial. Okay, so here if we use this formula, what we get instead of a, sorry, this should be a, since there is a over here, instead of a we have 2 alpha, so we will just replace this a by 2 alpha, and instead of n we have 2. So what we get, 4 pi c square 0 to infinity, we will just replace this formula, gamma 2 n is 2 plus 1, that is gamma 3, divided by 2 alpha raised to what? 3. This should be equal to 1, and gamma 3 you know nothing but 2 factorial. So at the end I get 4 pi c square into 2 divided by 8 alpha cube should be equal to 1. You can see this 4, 2 and this 8 will get cancelled, and what I will be left with, so c is equal to under root alpha cube divided by pi. So this is my normalization constant, and therefore psi of r bar, I can write down this as c square means alpha cube by pi e raised to minus alpha r. Okay, we obtained c. Now you know what is our next step. Next step is to obtain E of alpha. We can write down this energy as like this: integration h bar square del psi square, this del psi star del psi can be written as del psi square plus v psi square dq bar. So this is nothing but del psi whole square and v psi square. This. Okay, so and I know what is psi. Psi is nothing but root alpha cube by pi e raised to minus alpha r. So let us just substitute that. E of alpha h bar square by 2m integration. This del in spherical coordinate is nothing but del r, and e raised to minus alpha r, this whole square. Also this factor will also get squared. I can take that outside, alpha cube by pi dq bar plus, now what is V for a ground state energy of hydrogen atom? Minus E square R for energy of hydrogen atom, minus E square by R, electrostatic potential, and alpha cube by pi e raised to minus 2 alpha r. since we are doing psi square over here. dq bar, you know what is dq bar? 4 pi r square dr, and also we will calculate this derivative. So h and this r will go inside since it is not a constant. So h bar square over 2m alpha cube divided by pi, and this derivative will be minus alpha e raised to minus alpha r whole square. So it will nothing but be alpha square e raised to minus 2 alpha r then 4 pi r square dr. Okay, minus e square alpha cube divided by pi, and then integration e raised to minus 2 alpha r upon r 4 pi r square dr. Okay, so now what I can do further, this 4 pi I can take common, this alpha square I can take common, and whatever I will be left will be, so let us just do that. H bar square, this alpha cube and this alpha square will become alpha raised to 5, 4 pi, and here it will be 2m pi. And what I will be left with, r square e raised to minus 2 alpha r, and of course this derivative will be from 0 to infinity. This is also from 0 to infinity. dr minus, and here 4 pi will be taken as common, e square r cube pi into 4 pi. 0 to infinity, this r and this r will get cancelled, so 1 r will be left over there, e raised to minus 2 alpha r dr. So now this, to calculate this, we already know this is definition of gamma function as we saw already. I will just write down it again. 0 to infinity x raised to n e raised to minus ax is nothing but gamma n plus 1 divided by a raised to n plus 1, and if you compare this integral, we know n is equal to 2, okay, and a is equal to 2 alpha. So let us just use that. So 2m pi, and now this integral will be gamma 2 plus 1, that is gamma 3 whole divided by 2 alpha raised to 3, okay, minus, now this part I will write down, e square r cube, alpha cube, this is alpha, e square alpha cube, this pi will get cancelled for now, into 4, and this integration n is equal to 1 when you use this formula, okay, and a is equal to 2 alpha. So if I use n is equal to 1, I get gamma 2 and 2 alpha raised to what? 3. So now it's time to simplify all the equations. So this pi will get cancelled over here. Also this 2 alpha cube, so this 2 alpha cube will become 8 alpha cube. So this alpha cube and alpha raised to 5 become alpha square. This gamma of 3 will become 2 factorial, which is nothing but 2, and this 2 will get cancelled, okay, this 4 will become 2 over here, and that's it, I guess. So what I am left with over here is h bar square, this alpha square, this 2 and this m divided by 2m, and over here this gamma of 2 is nothing but 1. This 2 alpha square will be there actually, since n is equal to 1 for this integral. N is equal to 1, and therefore m plus 1 plus 1 will be 2 over here. So this will be 4 alpha square. So this 4 will get cancelled. This alpha square. So here only alpha will be left. So finally what I will have over here is alpha E square. So this is nothing but h bar square alpha square upon 2m minus alpha E square. So we obtained this using this formula. If you are wondering, since we know that this trial wave function is continuous for first derivative as well as second derivative, we can use the original formula for Hamiltonian and also get the same result. That same thing is done over here. We use the del 2 function and obtain the same result at the end. As you can see, we obtain the same result, h bar square alpha square by 2m minus alpha E square. Same we obtained. Okay, so we obtained E of alpha. Our third step is to minimize this E by calculating del E by d alpha and equating it to 0. Okay, so we know what was our E. Our E was h bar square alpha square upon 2m minus alpha E square. Let us take the derivative of this. So what I will have h bar square alpha divided by 2m, sorry, this 2 will be gone. So let me just erase this. So h bar square alpha upon m minus derivative of alpha is 1 E square, this should be equal to 0. So we get alpha is equal to m E square h bar square. So this is my alpha. I substitute this in E. What I will get? E minimum. So E minimum is nothing but h bar square by 2m, and this alpha square is nothing but m square E raised to 4 upon h bar raised to 4 minus m E raised to 4 upon h bar square. So I can simplify this h bar square and this h bar square will get cancelled. One h bar square in the denominator will be left. So I will be left with m and this m square. 1m from m square will get cancelled. 2h bar square minus m e raised to 4 on h bar square, which is nothing but minus m e raised to 4 divided by 2h bar square. So this is the ground state energy that we found out using a trial wave function. Okay, this is E minimum that we obtained, and this would be nearly equal to the exact value of ground state energy. Okay, but now we see the ground state wave function that we used e raised to minus alpha r and c factor, which was of course alpha cube by pi, and what we calculate alpha as for ground state energy, this. So we will substitute that over there. So what we will have, m cube e raised to 6 divided by pi h bar raised to 4 and 1 by 2 over here, and e raised to minus m e square upon h bar square r. So if you find out, this is nothing but the ground state energy of the hydrogen atom. If you look at the textbook, and this is the ground state energy. So our trial wave function was nothing but our exact wave function, and therefore this ground state energy that we obtained is also the exact ground state energy of the hydrogen atom, and this is not the approximate one. Okay, so I hope this is clear for you. How do we use this formula for Hamiltonian to solve the 3D problems using the variational principle? We will see few more problems. Okay, so thanks for watching this video. Bye.